Hello, my BC children. I'm looking at section 9.7, differentiating in polar form for today. And you have not been familiarized with polar functions, polar equations. So the first thing that I'd like for you to do is go to our classroom page and watch a short 10-minute video giving you an introduction to polar equations and polar forms. So it might make some of this make a little bit more sense. So once you've done that, then you want to dial into this. So here we go. XY is for a rectangular coordinate system. Sometimes we call it the Cartesian plane. And all of our points have an x coordinate and a y coordinate. Back to regular old, we're not talking about vectors. We're talking about just regular old xy points. So a rectangular coordinate system. But in the polar system, it's r comma theta instead of x comma y. R is a directed distance from the origin to a point P, and theta is the directed angle. So here's what it looks like. You have some point P over here. And in our system, that would be an xy coordinate, a point P. And so from the origin to that point P is what we're looking at. That would be your r value. And then the theta value is this value here coming from the positive x-axis to your r, to that r place. It's the directed angle. So if I'm looking at that, it actually has, if I were to think about this, equivalence with an x value on your plane and a y value on your plane. But it just has a direction to it, which is what makes it a little bit different. So instead of it being a plain old coordinate xy, it's now an r value and a theta value. So there's a way to convert, and that's what this next chart is all about. These are your conversions, because it's going to ask you in some questions to go from polar to rectangular, and in other questions from rectangular to polar. And so we need to know how to do that. Some other things that are interesting about polar coordinates is that they have equivalents in weird places. Like, for example, if I have a coordinate that's 3 comma pi over 4, that means it has a length of 3 and its direction is pi over 4. It's actually almost about what this picture represents. It could also be represented, and this is what the video helps with, it also could be represented as -3 5 pi over 4. That would be down here. That would be over in the third quadrant with a direction of 5 pi over 4, but it would be in a -3 value. Instead of it going this way, it actually would come back this way, so it would be equivalent to this. It's going in the opposite direction, that -3. It could also be equivalent to -3, just -3, not -3. With a fraction, -3, and -3 pi over 4. Well, -3 pi over 4 is actually the same place as positive 5 pi over 4, so the same reasoning goes with it. It would be a length of 3 for r, but you would have, it's a -3, so instead of it being down here, it would be opposite it, which would be up here. Again, the video probably does a better job of explaining that. But anyway. Here we go. Convert the following from polar to rectangular. Well, we know that r cosine of theta can be replaced with an x. R cosine of theta can be replaced with an x. And there you go. You're done. It's actually that easy. Maybe nice if you could see what I'm writing. There you go. All right. Same thing goes for number 2, except r cosine of theta has a 4 in front of it. R cosine of theta represents x from my conversions here. So this is like 4x equals r squared. Well, r squared comes from this, x squared plus y squared. So I could say x squared plus y squared. So in looking at this, let's see if we can pull it all together. I would have, if I put everything on the same side of the equal sign, I'd have x squared minus 4x plus y squared equals 0. Well, I can figure out, you know that x squared plus y squared equals r squared is the formula for a circle. This is a circle, but the center of the circle is a little bit adjusted. So what you do is you complete the square. When's the last time you completed the square? X squared minus 4x, leave a blank, plus y squared equals 0 plus something. So if you remember with completing this square, it's half the middle term squared. So negative 4 divided by 2 is negative 2. Negative 2 squared is 4, so plus 4 here. Algebra balance makes me add 4 to the other side. If I were to factor this, it's x minus 2 quantity squared plus y squared equals 4. That is now a circle, and you know it's a circle with a center at positive 2, 0. Remember that takes the opposite sign. And the radius is the square root of 4, which is 2. So it would be a circle with a center at 2, 0 and a radius of 2. Number 3. This one I have, I'm trying to put this into rectangular form. I don't have anything I can directly substitute, like the r cosine of theta that I did in the last couple. So the only thing I can do with this, now you know I always think about cross multiplying, but you can just think about multiplying both sides by this denominator either way. 4 times 1 is 4. R times 2 cosine of theta minus the sine of theta. Watch how I'm going to write this. The r gets multiplied by both of those, so it's going to be 2r cosine of theta minus r sine of theta. So I took that r and I distributed it to both pieces. And what that's going to do is let me do my substitution. Now I know what r cosine of theta is, and I know what r sine of theta is, and so I can replace that in there. 4 equals 2x minus y. This could be one of those multiple choice questions that you could see it in a lot of different forms that are equivalent. So maybe you probably might see it as y equals 2x minus 4, but they're one and the same thing. So no big deal. All right, next thing is slope of a curve in polar form. Well, the slope is the derivative. And all right, so the derivative of dy over dx is defined the same way that the derivative of a parametric equation is. So I'm going to show you a couple different forms. The first one is y prime. But this time, instead of it being in terms of t, like it was with parametrics, it's in terms of theta. So it's the derivative of y in terms of theta over the derivative of x in terms of theta. But notice they said that I had r is f of theta. So here's another way you could see it. F of theta times the sine of theta. And you might say, where are you getting that from, Winner? Not squared. Sorry, that's coming up in a minute. This is a prime. And the reason is this is r theta, right? R times the sine of theta. You've got y values are the sine of theta, and the x values are the cosine. So cosine would be f of theta times the cosine of theta, and you want the derivative of that. Which means, if I take this thing and find the derivative, I need a drink. Hold on just a sec. If I take the derivative of this, think about what rule you'd have to apply to take that derivative. Hopefully you said product rule. Here it is. Product rule. So if I product rule this thing, I have the first, f of theta, times the derivative of the second, derivative of sine is cosine, plus the second, that would be sine of theta, times the derivative of the first. All right. Do the same thing on the bottom. First times the derivative of the second. Oh, that's going to be a negative sine of theta, plus the second times the derivative of the first. And so there you go. That's going to help us out in finding what the slope is. So it's kind of like a product rule in the midst. All right, let's flip and try some examples. These are, the following examples are common problems that are found on the AP exam. So number 4 says, all right, what's the slope of the line tangent to the polar curve r equals 1 plus the sine of theta at theta equals 0? So we're looking for the slope, I'll put it in our margin here, the slope at 0. So that would be y prime of 0 over x prime of 0. Right? That's what we're looking for. What the slope's going to be when theta is 0. All right, well, we got to talk about what x is and what y is in the process, and then we have to derivative them as well. So all I know right now is that I've got an r that represents this equation. All right, so here's what my x is going to be. Remember, x is r times the cosine of theta. We're starting out with that fact. Well, what do you know that r is? Well, r is 1 plus 2 sine of theta. So 1 plus 2 sine of theta is my r, and then times a cosine of theta. And I know I'm going in the direction of having to find the derivative, so I want to put it in a form that's going to be nice. I'm going to distribute this cosine into this. So I'd have 1 times cosine is cosine, and this guy's going to be 2 sine of theta cosine of theta. And then I have to derivative it. Well, x prime. Derivative of cosine is negative sine plus, no, you say, I've got to product rule this thing. So, all right, we can do that. The first times the derivative of the second. Derivative of cosine is sine. I'm sorry, negative sine, right? And then plus the second cosine times derivative of the first, that would be 2 cosine. I guess I could bracket that off. Now you can distribute this out, make this a sine squared, make this a cosine squared, but I'm going to keep it the way it is because they're asking me to evaluate it, and they're asking me to evaluate it when the theta is 0. So I want to know when I'm at 0, what's the coordinate that goes with 0? So 0 would be 1 comma 0. So let's see if we plug it in, if it's going to help us get a number. Sine is the y value, so negative 0 is just 0, plus 2 times 0 times 0 is still 0, plus, I'm here, cosine is 1 times 2 times 1. 0 plus 0 plus 2 is 2. There's my x prime. All right, now I'm going to go for the y's. Do the same thing, same concept. I'm going to go with the fact that I know that y is r sine of theta. What do I know r is? R is 1 plus 2 sine of theta times another sine of theta. That's going to give me, distribute the sine in, sine times 1 is sine. 2 times sine is 2 sine squared theta. Put in your derivative, that's next, y prime. Derivative of sine is cosine. This one, the 2 comes down, times is by the 2 in front, becomes a 4. Sine of theta to 1 less power, so now instead of it being squared, it's just a singleton, times the derivative of sine, which is cosine. And now I'm ready to figure out what y prime is 0 is. I guess I should have put that over here as a 0. All right, there we go. Cosine is the x value, so that is 1 plus 4 times 0, sine of theta is 0, I'm going back to this fact over here, times a cosine, which is times 1, but it still is, there's a 0 involved, so all of this comes out to be a 1. And so, if I go back to my original problem, you can't see it all on the same screen, but you kind of can. If I go back to my original over here, what is y prime of 0? Well, y prime of 0 is 1. What's x prime of 0? That's 2. And so guess what my slope is at that place? It's 1 over 2. And so that's my final best answer. That's number 4. Number 5. This one, if I look at it, I'm trying to grab some highlighters here. Find the horizontal and vertical tangent lines of r equals 1 minus the sine of theta on the interval from 0 to 2 pi. And so if I look at the picture, and just looking at the picture, think about horizontal tangent lines. Horizontal tangent lines, there would be one here, there would be one here. And believe it or not, they're not the same thing. And that's because, remember how these are directional? This one's in the first quadrant, so the angle has to be somewhere between 0 and pi over 2, where this one's in the second quadrant, so its angle has to be between pi over 2 and pi. But then there's another place here, so there should be 3 horizontal tangent lines for this guy, and there should be 2 that are vertical. So right off the bat, I know how many answers I'm looking for, but geez, I have no idea what they are. So I'm going to go into trying to figure this out. If I am a horizontal tangent line, then my slope equals 0. Right? This is an m equals 0. And if I'm a vertical tangent line, then I am an m that's undefined. Remember, undefined with slope, dude. So what part of the fraction, you know you've got a slope, so you've got a y value on the top, y prime, and you've got an x prime value on the bottom. If I'm horizontal and my slope is 0, what part of that fraction determines that value? Is it the numerator or the denominator? And hopefully you're saying if it's going to equal 0, that it's the numerator. So I want to know when does y prime equal 0? That's this. That's when the slope is 0. The slope is undefined when the denominator is equal to 0. Well, our denominator is x prime. So I want to know when does x prime equal 0? And so really, if you think it through of what direction you're trying to go, that's the direction you want. So we need to figure out what x prime is, we need to figure out what y prime is, and we're going to take them in their right places and set them equal to 0. So let's go horizontal first. Write small, by the way. This gets a little bit cumbersome. Horizontal, I need to know horizontal when y prime equals 0. So let's go for finding y prime. First of all, I got to get to y. We know that y equals r sine of theta. What do you know r is? Just like the last problem. In the last problem, r is 1 minus the sine. And I have to multiply that by another sine. And so I distribute that through. I'm still worth y. I haven't even gone to y prime yet. Sine of theta minus the sine squared of theta. Now I'm ready to derivative. And so if I derivative this, derivative of sine is cosine. Oh, minus, not equals. Derivative of sine squared, 2 comes down in front. The sine goes to 1 less power times the derivative of sine, which is cosine. Set it equal to 0. Now, if this were, and it was funny in class, you guys said this, if this were a calculator question, you could go to your calculator and have your calculator solve it for you with the solve button in our 89s. But let's just go back to pre-calc for a minute and see if we can remember how to solve these. If I factor out a cosine, because my two terms both have a cosine, I would be 1 minus 2 sine. And I take both of those pieces and set them equal to 0. So now I have the cosine of theta equals 0 from this factored out part, and 1 minus 2 sine of theta equals 0 on the other part. Well, cosine is 0. You've got to go back to your unit circle, and we created it actually in class today, so just for you to remember it. It was pi over 2 and 3 pi over 2. That's when cosine is 0, when the x value is 0. This one is when the sine equals 1/2. So you go to your circle again and you get pi over 6 and 5 pi over 6 when the y value is 1/2. And you say, wait a minute, I have 3 horizontal tangent lines and I have 4 answers. Doesn't work that way. So you've got to go to your calculator, and we're going to look at, real quick, first of all, we are in polar form. Let me see if I can get this where you can see me. There we go. So thing number 1, go to your home menu, change your mode. You're right now, well, I'm right now in function mode. If I do my right arrow and go down to, now I can be in polar. Press enter, enter, go to y equals. Oh, check it out, they're all r's, which makes sense. So you're going to put in your r, what you have for your original equation, 1 minus the sine of theta. Now theta is next to the pi. It's over with your caret, so it's green and then pi gives you the theta. And so you can see there's my equation just like my r should be. Cool. Go to graph it. I can, it's kind of small to see. Let me see if I can change my window a bit or zoom it. F2, let's zoom in. There it is. Okay. I'm not quite as circular, but that's okay. You get the idea. So if I go to the table and I look at the table for this thing and I put in my 3 values, I put in a pi over 2. Is it going to let me? Table. Hold on. Table set. Okay, now. Pi divided by 2. Ooh, gives me 0. Huh. Let's try the next one. 3 pi over 2. 3 pi divided by 2 gives me 2. Okay, well that's better. How about pi over 6? Gives me 1/2. If I go to 5 pi over 6, I get a half again. So of my 4 choices, which one do you think is the one that's extraneous? And it's this guy here at 0. So he is my extraneous one. Remember what it means to be extraneous? It's an answer, but it doesn't work in the problem. And really what it is, it's this coordinate right here. This coordinate where the point is your pi over 2 place. Now what do you know about derivatives and pointy places? They can't happen, so there you go. Pi over 2. So your answers are, if I were looking at this, for my horizontal tangent lines, 3 pi over 2, pi over 6, and 5 pi over 6. All right, so then I'm going to go on to calculating out my verticals. All right, here come the verticals. Well, that's when the x derivative is equal to 0. So let's know what x is. Our fact is that x equals r cosine of theta. We know what r is. So x equals 1 minus the sine of theta times the cosine of theta. Oops, I don't need an extra parenthesis there. And then I distribute it through because I'm going to try to get to a derivative. Cosine times 1 is cosine. And I have a sine times cosine. Both pieces have a cosine. I can factor it out. Actually, no, let me derivative first. So x prime. Ooh, x prime. So if I have that, I have the derivative of cosine is negative sine minus product rule first times the derivative of the second. Derivative of cosine is negative sine, makes this plus. Maybe I don't like changing it there. Hold on. Let's leave it as minus. We're going to leave this as a negative sine. And then plus the second cosine times the derivative of the first. Well, the derivative of sine is cosine. So here's where it puts me, and this is going to be really interesting. Negative sine of theta, and then it's going to be, is it plus or minus? Negative is plus sine squared of theta. But I have a negative and a positive makes this minus a cosine squared theta. So watch your signs in the midst of that. And in looking at this, my only options are to be able to try to factor it or something like that to solve it out. And you can't factor when you've got two different variables involved in the whole equation. So there's got to be some magic that you can perform to make this thing factorable. One thought I have is, well, is this your Pythagorean identity we've seen with sine squared plus cosine squared? And the problem is it's not. So here's the magic. You know that cosine squared by a Pythagorean identity is equal to, think of this, sine squared plus cosine squared equals 1. If you take that and solve it for cosine squared, it's 1 minus the sine squared. Pythagorean identity. And what's going to happen is when I distribute this out and put this all together, then I'm going to have a function that's only in terms of sine, which is going to allow me then to factor. All right, here goes. X prime equals negative sine of theta plus sine squared of theta minus 1 minus negative sine squared, so plus sine squared theta. So I just distributed through the negative. Now I'm going to combine like terms and put it in a factorable position. I will have 2 sine squareds. I will have a minus sign, and I will have a minus 1. And if you think about that back in the days of factoring, regular old factoring, it kind of would be like 2x squared minus x minus 1, with my x's being signs. So if I think of that, and I factor this thing, it's going to be 2 sine of theta, and it is plus 1, and then sine of theta minus 1. I think I've duly run out of space. All right, let me go. I'm going to go into box 1 because I'm not going to do 1 as an example. All right, so here I am. I want to take these things and I want to set this equal to 0. So 0 equals 2 sine of theta plus 1 times sine of theta minus 1. Means I have sine of theta equals a negative 1/2, pull the 1 over, becomes negative, divide by 2, and the sine of theta equals 1. So again, I go through my unit circle. It equals negative 1/2 when theta, this is when your y value is a negative 1/2, that would be 7 pi over 6 and 11 pi over 6. And then the sine is 1 when theta is pi over 2. So looking at my picture, I have 3 answers and I have 2 places where I have vertical tangent lines, my 2 blue lines here. And so if I'm looking at this, there's one that I need to eliminate. Well, you already saw this. This was the same situation back when we did the y's. The pi over 2 is your pointy place. He's your extraneous value, which means your 2 answers are 7 pi over 6 and 11 pi over 6. Makes sense. Now let's put it all together actually. This horizontal tangent line, this one is going to be your pi over 6 because pi over 6 is in the first quadrant. Second quadrant is going to be 5 pi over 6. That's this guy here. In the third quadrant, it's at 3 pi over 2. Well, this is 3 pi over 2 right here. For my blue line, 7 pi over 6 and 11 pi over 6. Yeah, this is the third quadrant, 7 pi over 6. And this one is the fourth quadrant, that's 11 pi over 6. It all should kind of line up with what you know about trigonometry and your quadrants and such. So there it is. Number 5, that final example. These are beastie problems. There's a lot to them. So, hang in there. This is not the easiest of sections. Number 2 is on our list of practice problems to look at. Find 2 sets of polar coordinates for the rectangular coordinate 4, -2, but limit your answers to just be between 0 and 2 pi. All right, so to be in polar from rectangular, you need an r value and a theta value. You need r and theta. Well, r is the easiest because you know the fact that r squared equals x squared plus y squared, right? We saw that on the front page. Well, r squared equals 4 squared plus -2 squared. Well, that would be 16 plus 4 more is 20. So r squared equals 20, which means that r equals the square root of 20. Now, when you square root that, that means it's plus or minus. So I really should put the plus or minus in the midst of that too. So plus or minus the square root of 20. Cool, we got an r value. Which, by the way, that's how you get the 2 sets. One has an r value of positive 20 and one has an r value of negative 20. If I were to put this thing now for theta, theta goes from, and if you look at your front page, it said this on your conversions, that the tangent of theta equals y over x, right? That's the regular old SOHCAHTOA kind of stuff. Well, in our case, the tangent of theta is a y value of -2 and an x value of 4, or -1/2. Now, in order to get that, -1/2 is not on our unit circle for a value for y divided by x. There's nowhere on there you're going to get a -1/2. So what you have to do is go to your calculator, and in your calculator you're going to put tangent to the -1 of, I would use the positive. This is going to get you a reference angle. I don't know if you remember me talking about that back in the day of pre-calc, but it gives you what's called a reference angle. So you go to your calculator, put in, make sure you're in radian mode, put in tangent to the -1 of 1/2, and it's going to pop out at you a 0.464. But then you have to put it in the right quadrants for where your tangent is negative, because remember this was a negative value, so I need to figure out where it's negative. Now think about tangent. All students take calculus. Everybody's positive in the first. Tangent's positive in the fourth. So that means that you are looking for quadrant 2 and quadrant all students take calculus. So tangent is positive in the third. So it's the second and the fourth quadrants that you're looking for. To put a reference angle in the second quadrant, it's pi minus the reference angle. To put it in the fourth quadrant, it's 2 pi minus the reference angle. If we're in the first quadrant, it would be equal to the reference angle, and if it's in the third quadrant, it's pi plus. It's been a long time since you've seen that, but nonetheless. So go to your calculator, find these values. 2.676. This is 5.816. And so the question wants to know, what are the 2 polar coordinates? So again, I'm going to go into box 4 just because I'm out of space here. One of them would be the positive square root of 20, and that goes with the 5.816 value. And then the negative square root of 20 is going with the 2.676. How do you know that? You graph it on your calculator and you make sure that you got it in the right places. Okay, that is number 2. I want to look at number 3 real quick. Number 5. Number 5 says, okay, there goes Levi. Number 5 says, sketch the curve. Now you saw this on the video how this works. It says without a calculator, but we're going to use the calculator to help us out a little bit. So if I look at this curve, this is 2 cosine of 3 theta. You need to set up a table, and we're going to make a large table. They did this in the video. They used the pi over 6 locations, and so we're kind of going to do the same thing. Alright, so if I look at this, the first place I'm looking at is 0. When theta is 0, well, the cosine of 0 is 1, and 1 times 2 is 2. Next one I'm going to do is pi over 12. That would be 3 times pi over 12, so that'd be like pi over 4. That's the square root of 2 over 2. The 2's cancel, and you get the square root of 2. Next one is pi over 6. Well, pi over 6 would be like 3 times pi over 6, or pi over 2. Pi over 2, the cosine is 0, so this would be 0 times 2, that's 0. Next one I want is pi over 4. That's 3 pi over 4. So now I'm at a negative square root of 2 over 2. 2's cancel, I get negative square root of 2. And you're going to do the same thing. You're going to continue this table, r and theta. Next one I used was pi over 3. That's like pi. Cosine of pi is negative 1. Negative 1 times 2 is negative 2. If I do 5 pi over 12, that would be 5 pi over 4. That's a negative square root of 2 over 2. The 2's cancel again. I get negative square root of 2. If I put in pi over 2, that is 3 pi over 2. That gives me a cosine that's 0. I'll try a few more. If I do r and theta, if I do 7 pi over 12, that ends up to be 21. So 7 pi over 4. That's a square root of 2 over 2 again. 2's cancel, square root of 2. If I do 2 pi over 3, wow, you think I should go check out Levi, make sure that he's all right? If I do 2 pi over 3, I am at 2, am I at 2 pi? 6 pi over 3, so I'm at 2 pi. That would be a 1, and 1 times 2 is 2. And then I'm going to do one more, 9 pi over 12. That is 27 over 12. That would be 27 over 12. Why am I brain farting that? 27 over 12, so I would be dividing by 3. That gives me 9, and this gives me 4. So 9 pi over 4, really I guess I should have stopped at the other one. So 9 pi over 4 is beyond my, I was only going up to pi. Well, these are pi's. Okay, so never mind. 9 pi over 12 gives me the 0 to close it out. So here's what you do. You go and graph these points. Now, it's probably easier on the calculator to help you out, but here's the first one, 2, 0. Square root of 2, pi over 12. Now, think about pi over 12. That would be itty-bitty, right? And you want a square root of 2, which is like a 1.414. And then at pi over 6, a little bit further, it's at 0. And then at pi over 4, it goes down here to negative square root of 2 over 2. So that would be over here. And then it goes to negative 2. And you're just going to plot these points around. I have, where did I get to? 0, 2, negative 2. Then I have this negative square root of 2 is 5 pi over 12. Well, 5 pi over 12 is over here, but it's a negative square root of 2. So it's down in the neighborhood. And then I go to 0 again. And then I go a positive square root of 2. That puts me up here. Actually, this one is off. This one's He is not there. I have a coordinate over here that's at negative square root of 2, and then I have another one that's out at 2, and you're like, what the heck are you graphing here? And here's what it looks like. You can check it on the calculator. And then it goes down in this neighborhood, and then up in this neighborhood. Now, I'm not the best drawer of these things, but it should be, just make this one a little wider, something like this, a petal, kind of a flower, and they should all be about the same size. I mean, my size is pretty bad. I guess when I did it on my notes, this picture's a little bit prettier. You get the idea. So 3 petals, they're all lovely, and there you go. All right, let me see what else I might want to do with you. I think the only one left that's different than what we've done, so I'm not keeping you forever and ever, is number 14. So let's look at number 14. There are not, by the way, this is the only graphing problem that I saw on any of the practice problems, or so far at least, for where I've gotten. So if you can't graph it, if the graphing is like killing you, don't worry about it. It's really not that big a deal. Most times, if this were an AP question, you would see it being calculator active. Most of these polar things usually are. All right, 14. I think we're going to end with number 14. For a certain polar curve, r equals f of theta, it's known that dx over d theta is this function and dy over d theta is this function. What's the value of, the second derivative at theta equals 3? Now, if you remember how to find the second derivatives, you have to go through the first derivative first. So the second derivative from our notes previously, d squared y dx squared, is the derivative of the y divided by the x. So the y is sine of theta plus theta cosine of theta over cosine of theta minus theta sine of theta, right? But then it's over dx over d theta, so it's over cosine of theta minus the sine of theta. And I want to find the derivative. I want to evaluate that when theta equals 3. And so thankfully, this is a calculator active problem. And I just wanted to remind you pretty much that when you're finding the second derivative, you've got to take the derivative of the first and then divide it by x prime. And so you go to your calculator, you plug in a 3 for all of these values, and you end up with a value of 5.5067. That's your numerator. Denominator is negative 1.4133, so that when you divide them, negative 3.896 is your final answer for that guy. Okay. Little bit of direction on number 16. I'm not going to do it out with you. This is a classic AP kind of question with all these multi-parts that you see. So this is something you could see again. If I'm looking at this, find speed. Now, we haven't talked about speed necessarily in this particular section, but you remember how to find speed, right? It's a square root of x prime. I'm going to use thetas. Squared plus y prime of theta squared. Speed is just that. The next thing it's talking about is the particle increasing or decreasing. Well, where does increasing and decreasing come from? Is that something that you get from a first derivative, from a second derivative, and hopefully you're saying first. So it's increasing when your first derivative is greater than 0, and it's decreasing when your first derivative is less than 0. So that should be no big deal. Is the speed increasing or decreasing at time t equals 5? So you're going to evaluate the derivative at that place, the derivative of speed, and then find the total distance. Remember total distance from the last, was it the last section? It's going to be the integral from A to B of this guy right here, your speed fraction, the speed, what am I thinking of? Square root. So I'll put speed in here. Maybe I should just put speed without this thing. You'll know what I'm talking about. So take the integral of speed for 0 to 6 seconds. And then the last thing says find the position at t equals 8. Well, this is totally calculator active, thankfully. So you want to figure out what p of 8 is. Did they give you p? I don't know about that. Did they give you p? They didn't. You've got to put that in. So p of 8 is going to be the, and this is a velocity vector, we're back to vectors, is x of 8 and y of 8. And then they want to know what's the velocity at t. So now I want to know what v of 8 is. So that means I'm doing x prime of 8. Let's show you. And y prime of 8. And then they say, okay, well, what's the position at 11? And so you're going to have to figure out position at 11. They've given you some values so that you can figure out the correct c value for this thing. And so that's going to be your last piece. You want to know what the v of, or I'm sorry, the p of 11 is. P of 11. All right, just to give you some heads up on how to do that last problem. So I will catch you in class, and you can email me if you've got any questions, and I will see you then. Hang in there. This was a hard section, so give it your best effort, and I'll see you soon. Bye.